Hi there, welcome to the Above Ground Storage Tanks online course. You are watching the summary video of Lesson 1, Codes and Design Conditions. This video is a quick overview of the different contents you have to get acquainted with prior to any development. The contents that will be covered in this module have been outlined to understand the design process of this element in order to arrive to an adequate design. Contents included in this lesson are Above Ground Storage Tanks Intro, API 650 code, covering the scope and organization, and also covering other applicable codes. Next, design conditions, including loads, internal and external pressure, and temperature. The first step in every design is to understand the purpose of the element to be designed, its main parts, what governs the design, and the applicable design codes. What are storage tanks designed for? Mainly to stock large quantities of fluid at relatively low installation cost. Some of their characteristics are: they are a buffer between the different stages of the process. They are easy to build compared to other similar equipment. They operate at atmospheric or near atmospheric conditions. Generally, they are built in situ. A storage tank is formed by a different number of parts as shown in the picture. The main three parts are the shell of the tank, the roof of the tank, and the bottom or base of the tank. As observed in the picture, there are different types of tank roofs, mainly depending on the process and site requirements. From the mechanical design point of view, it is mandatory to fully understand the roof configuration in order to design the parts of the tank, but more importantly, to determine the loads to be supported. Tanks are selected upon several different parameters. The main ones are process requirements, fluid characteristics, and site conditions. From the different types of roofs seen previously, the most used ones are fixed roof, mainly used to store non-volatile products such as water, ethylene, glycol, etc. And floating roof type, mainly used for volatile fluids such as petroleum and its derivatives. It is worth mentioning that the roof selection governs the tank design. The purpose of using design codes is to avoid disasters that can affect humans. Therefore, they comprise a range of experiences and good practices. Before we start reviewing the code organization and the minimum requirements, it is convenient to establish the main differences between the equipment used to store products. A good comparison could be made regarding the pressure level to which they can operate. Storage tanks designed according to the API 650 code are also known as atmospheric or low pressure tanks, since they can only operate with internal pressures below 17 kilopascals. The API 650 code from the American Petroleum Institute is divided in two main parts. In the first part of the code, the mandatory requirements are found, where the scope, definitions, and main contents are included. In the second part, we find the annexes, a set of good practices, recommendations, and examples. The mandatory requirements are divided into 10 sections, covering the complete fabrication and installation cycle of a tank. From the mechanical design perspective, the most relevant parts are materials, design, and fabrication. On the other hand, the code has 27 annexes, covering the different roof types, internal and external pressure considerations, seismic design, and allowable nozzle loads, among others. The code states the minimum requirements for the design, fabrication, material selection, inspection, and installation of tanks fabricated with steel welded plates. Tanks designed with this code must meet the following requirements. Tanks can only store liquid fluids. The bottom of the tank must be sand, gravel, or concrete supported. The internal pressure in the tank must be lower than 17 kilopascals, and the operating temperature has to be lower than 93 degrees, going up to 260 if Annex M requirements are met. The adequate definition of the design condition is a stepping stone of any satisfactory design. In some cases, the real difficulty of the calculation process lies with definition of the design conditions. Pressure and temperature are just two of the many design constraints that should be taken into account. Some of them are ambient temperature or fluid temperature, pressure requirements, either internal or external, loading, as in self-loads, live or dead loads, liquid level, corrosion allowance, external requirements, site conditions such as wind, seismic or snow, capacity, diameter, height, and fabrication requirements. Due to the large quantities of product that could be stored in this type of equipment, load definition is one of the fundamental aspects to be evaluated prior to any development. The loads that generally govern the design of storage tanks are the operating weight of the fluid, seismic loads, and the wind pressure, these two last conditions depending on the site. All loads acting simultaneously upon the tank must be taken into account. Therefore, the different design scenarios are determined, checking the tank against every possible case until the most stringent is found. This video is just a quick overview of the different contents you have to get acquainted with. You should check and understand the different contents mentioned in this video in the study notes prior any development. Remember that all concepts dealt with are complementary and that assignments are linked. Keep up with the woodwork and come back for more. Thank you and have a great day.